Sketch the graph of the following function. F of x equals x cubed minus 3x squared plus 3. First find your domain and your range for the function. For our domain, we know that x is an element of all real numbers, and our range y is an element of all real numbers. Find where your graph crosses the x-axis, i.e. your x-intercepts. Equating f of x to 0, we find that our x-intercepts are negative 0, 8, 7, 9, 1, 3, 4, 7, and 2, 5, 3, 2. Find where your graph crosses the y-axis, i.e. your y-intercept. For our y-intercept, letting x equal 0, it gives us y equals 3. Find the first derivative for the equation of the function. F prime of x equals 3x squared minus 6x. Equating the first derivative to 0, we are able to find the x coordinates for our turning points. So 3x times x minus 2 equals 0. And x equals 0 or 2. Looking at the graph of our first derivative, we know that f prime of x is greater than 0 on the interval negative infinity and 0, and infinity. Thus, f of x is increasing on the interval negative infinity and 0 and 2 to infinity. And f prime of x is smaller than 0 on the interval 0 and 2. And f of x is decreasing on the interval 0 and 2. Find the second derivative for the equation of the function. F double prime of x equals 6x minus 6. Looking at the graph of the second derivative for the equation, we can see that f double prime of x is greater than 0 on 1 to infinity. Because f double prime of x is positive, it is concave up on the interval 1 to infinity. And f double prime of x is smaller than 0 on negative infinity 1. Because f double prime of x is negative, it is concave down on the interval negative infinity and 1. Equating the second derivative to 0, we are able to find our point of inflection. F double prime of x equals 0 when x equals 1. Now, using our table of important information, we're able to sketch the graph.